Jai Hind all. Myself Pradeep Kumar Tripathi, Assistant Professor in Department of Information Technology, Ajay Kumar Garg Engineering College. Today we have discussed about the database management system, that is in third year subject. Subject code is KCS 501. Today we have discussed about the introduction part of the database management system. So now we have started the unit first lecture of this series. So we can conclude overview of the DBMS. So in the introduction part, then we have discussed about the need of the database, why we need the database, and after that we have discussed about the database architecture. Then we have discussed about the data models, data schemas, instances, then data independence, then brief overview of the DDL, DML and SQL part, that is also related to the introduction part. Then after we have in the next series lectures, we have discussed about the ER diagram, mapping constraint, that is all about the introduction part. Now we have started from the need of the database. What is database? Database, that is used for the storing the data, and DBMS is a system that manages the database. So we understand the how the database can be implemented by using the DBMS. Suppose we have some data, then we need a database. If we discuss about the applications of the database, then it is required in the banking sector, airline sector, universities, sales processes, online retailers, manufacturing, human resources. There are lots of areas that we have to use the database. So database is where applicable, where data is available. When talk about the data, then data must be stored in the database. When database comes into the picture, then DBMS also come into the picture, because DBMS contain the information about any particular database or any organization or enterprises. Suppose we have talk about the banking sector, then we have lots of transactions done in the whole day. So we can maintain that particular transaction in a particular database. So how we manage the database? Then we have developed a system that is called DBMS, then best utilization of a database. So we talk about DBMS. So DBMS is a contain the information about a particular enterprises, that is collection of interrelated data, set of programs to access the data, and an environment that is both convenient and efficient to use that particular DBMS data. These are the applications where we can use the database application. In suppose we have talked about the banking, all the transaction that must be stored into the database. In the airline sector, we have also the reservation process and schedules, that is also required for the database. In universities, we have talked about the university, then student registrations, grades, passing results, carryover papers, lots of records that must be stored in a database, because we have need a data after long time, after some time. So we have store the data into the database. So database is must for the every applications that we have to use in current days. So it is a need of today. We can use the database. In the database, then we can manage particular database. So we have developed a system of DBMS that we can manage that particular database. In suppose sales, we have customer, products and purchase, then these are the records that we use the database. Online retailers, order tracking, customization, recommendations, these are the sectors we have used the database. In the manufacturing, we have talked about the production, inventory, orders, supply chain. We have also lots of fields that we have to use the databases. Database can be very large. Database all aspects of our life. Today with scenario we cannot skip the database because we have lots of data and that must be stored in a database, and in the when we store the data in a database, then we can also manage that particular database by using the DBMS. So DBMS is very much important for that purpose. So in university applications, lots of records are there: faculty records, course records, instructor records, class rosters, grade points, carryover results, and there are lots of data that must be stored in a database and manage that particular data. So it is the basic that we have to use the database for the particular purpose of storing the data. In previous scenario, if we talk about the 1980s and 1970s, in that particular scenario we can use the file system. Nowadays we have used the DBMS. How the difference between file system and DBMS? What is file system? What is DBMS? How the difference between these two? Why it is needed to DBMS? File system basically was early attempt to computerization the manual system. It is also called traditional based approach, which a decentralized approach was taken where each department store and control its own data with the help of data processing specialist. In the file system, we can also store the data in the particular form of file. When we access that particular file, we have lots of problem to access that particular file because there is no arrangement to arrange that particular file in a folder. So it is need to a very effective and structured manner that we can store the file, and after the store the file we can also access that particular easily. So overcome the data redundancy, we need a centralized system that we use this type of problem. That is the resolution of this particular problem that is created by the file system. So DBMS comes into the picture. When we use the file system, there are lots of problems that occurs in the particular scenario. So we can develop a system that overcome the data redundancy. We need to create a centralized system and we use the DBMS approach. So we can use the DBMS approach. If we talk about what is the drawbacks of that particular system, so there are some points we have discussed about what is the file system drawbacks. After the drawback, DBMS comes into the picture. So first drawback is that is discuss about data redundancy and inconsistency. What is data redundancy and inconsistency? The data redundancy means that is the number of records, duplication of the information that is stored into the file, because file is a no way arranged manner, no way to arrange the records in the arranged manner. So it may be possible data redundancy may be exist. So data redundancy, and there are multiple formats, file formats also, because suppose I am saving some data in a particular form of Word format. Suppose someone can use the Excel file, that also can be stored the data into the file. So there are two formats available in that particular file. One is Word, one is Excel. So data redundancy and inconsistency, these concerned about the multiple file formats, duplication of information in a different files. There are first drawbacks, that is the use file system. So now let's talk about the difficulty in accessing the data. What is difficulty in accessing the data? Need to write a new program to carry out each new task. When we store unstructured manner of our data, then when we going to access, there are lots of difficulties was there, because we have stored the data in the terms of unarranged manner. Then when we retrieve that particular data, then we are facing the problems, because some accessing time is more, some wrong data may be reflected. So there are lots of problem in accessing that particular data. So we can move on file system to DBMS. The third drawback is data isolation. What is data isolation? Multiple file and formats are there, because there is no isolation in between the data and data formats. In the fourth problem, we have discussed about the integrity problem. Integrity constraint, that means suppose we have taken the example of amount balance is greater than 0, become buried in the program code rather than being stated explicitly. Hard to add new constraint or change new one. If suppose we have using the some conditions or some integrity constraint, after some time we want to change some integrity constraint or some add new constraint, there is no way to change that particular constraint. It is very difficult to add new constraint or change of existing one. So that is the problem. We need to replace a particular system. Then atomicity of update, that is the next drawback. The failure may leave database in an inconsistent state with the partial update of carried out. Suppose example, we have taken the transfer of funds from one account to another account should either complete or not happen at all. In the particular file system, suppose we have maintaining the data, then atomicity of update that not be updated in that particular file system. So we can introduce the new system, that is DBMS, that can be ensure atomicity of updates. So these are the some drawbacks that is in file system. So we can introduce the new system, that is called DBMS. And some more drawbacks, that is concurrent access by the multiple user and security problems are also there in particular file system. So we can replace by the using DBMS system. So we have discussed about the file system and DBMS. DBMS is a system that manages that particular database in arranged manner, that is called DBMS. In the file system, we can store simply just creating the file folders and store that particular file in the particular folder. So some drawbacks in the file system, then DBMS comes into the picture. Nowadays we have used the DBMS. We cannot use the file system because file system is so many of drawbacks. There are lots of drawbacks that database system offers solution to all our problems, that is called DBMS. So we have discussed about what is the problem occurs in that particular file system. We can also introduce the DBMS system. Now we have discussed about architecture, how it is designed, how it is work, how it is flow for particular data. If we talk about the database architecture, that is greatly influenced by the underlying computer system on which database is running. There are 4 types. One is centralized, client server, parallel and distributed. The database design or DBMS design depends on its architecture. This is the client server. Basically we can send some request to the server, server can respond that particular request. So in this way we can use client server request. If we talk about centralized system, one system can handle all the queries. If that particular system can fail, then centralized system will fail. So there are options are there in the database architecture. By using these architecture, we can design our database. If we required multiprocessor environment, then we can use parallel. If we use the distributed environment, then we can use distributed system architecture. So we are depending on the architecture, because some requirements are there. Some requirements is centralized system, then we can use centralized database architecture. Client server, then we use client server database architecture, multiprocessor and distribute. So these are the architecture that we can use in a particular requirement or particular organization. So DBMS architecture, we can decide about the architecture 1 tier, 2 tier and 3 tier architecture. What do you mean 1 tier, 2 tier and 3 tier? In the 1 tier application, we can use some client, and this is the server. This is called client server. Suppose 1 tier, there is no application layer between the client and server. If we introduce some interface between client and server, suppose we have a server, we have a client, and client send the request to the application, then application can send the request to the server. This is called 2 tier architecture. This is 1 tier architecture. So this can be replied by this and replied by this. So it is called 1 tier, 2 tier and 3 tier. In the 3 tier, we can also use some, suppose client send the request to the one interface. Interface can send the request for the interface between server, then server can handle all the things. This is the 3 tier architecture. In 3 tier architecture, client can send a request to the interface, interface send to the interface of server, then server take the request. After the server replying the interface, then this interface goes to the this application, then this application goes to the client. So these are the basic architecture that we follow in particular DBMS architecture. So talk about 1 tier architecture. The database is directly available to the user. It means user can directly sit on the database and use it. Any changes can be occur directly done by the database itself. The 1 tier architecture is used for the development of local application when the programmer can directly communicate to the database for quick response. Then we can use the 1 tier architecture. If we talk about the 2 tier architecture, the 2 tier architecture is basically same as the client server architecture. We can use the APIs like ODBC and JDBC in the Java programming. Then we can use this type of interface between the client and server. Then we can use 2 tier architecture. In 3 tier architecture, there is another layer between the client and server. Client cannot directly communicate with the server. They interact with the application server and further communication with the database system. So let's we have discussed about these diagrams. This is the summary of these architecture: 1 tier, 2 tier and 3 tier architecture. If we talk about the architecture, these are the shortcuts. These are the basic outlet. So it is all about the architecture of database. Now let's discuss about the after the architecture. We can design some model. We can design some model that can relate to the directly the data. In this lecture, we have already discussed about the what is data, what is database, what is DBMS, what is file system, what is the drawbacks of the file system. Then after we can discuss about the database architectures, and after that database architecture we can design some model. What is the model? In data models, a collection of tools for describing the data relationship, data semantics, data constraints. Now let's discuss about the data models. In the data model, that is the modeling of data descriptions and data semantics and consistency of the constraint of the data. We have discussed about the relational data model, semi-structured, ER model and object-oriented models. Suppose we have a table, these are the tables. Suppose we have stored that particular data in form of table. This is called attributes. These are called attributes. These are called records. Records are also called by the row. Suppose row is a tuple. The columns are known as attribute, or it is also called the fields. These are the tables that we can store the data in the form of tables, and we can relate that particular data tables with the help of one column, that is department name. In the data model, relational data model, entity relationship data model and object based data model and semi-structured model. In the first, that is EF code, that is invented in 1969, that is called relational model. They can use the models design the data in the form of row and column within the table, and data and in between data relationship that is exist in the particular model. After the relational model, we can develop the model of entity relationship model. What is entity? Entity is a real world things that can be exist in the particular nature, and that entity must be related with each other. Then we have model, created the model and relate the entities. This is called entity relationship model, that is invented by the Peter Chen in 1976. After the ER model, we can develop about the object oriented model, object based data model, because we can introduce the some OOPS concept in that particular data model. Suppose we have a encapsulation, polymorphism, these concepts we have introduced in the ER model. This is called extension of ER model. So object based data model comes into the picture in the year of 1980s. After the object based model, we can introduce the semi-structured data model. Semi-structured data model, that is use the concept of XML. After the data models, we can discuss about the data instances and schemas. The overall design of a database is called a schema, and a particular movement, the data which is stored in the database is called instance of a database. We can use the schema concept, contains the object like tables, foreign key, primary key, views, columns, data types, stored procedures like these etc. A database schema can be represented by the visual diagrams. That diagram shows the database object and relationship between each other. The designer of a database must be develop some overall design that help the programmer to program that particular database. So schema is so important for the programmer, because programmer can refer that particular schema to design the database. So schema, that means overall design of a database, and the instance, that is the data which is stored at a particular moment in the database, is called instance. After the data model and data schema and instances, we can discuss about the data independence, because that data independence means there are three types of architecture that we have used, and we have discussed about this: 1 tier, 2 tier and 3 tier. In these architectures, data must be explained by using these schemas. There are some data independence that exists between these two schemas, because some data must be in one label and some data in second label. If we changing the labels, if we changing the data between these two labels, then data concept and data schema must be remain unchanged. In the data independence, we have discussed about the data independence. So there are two types of data independence. One is logical data independence, another is physical data independence. If we discuss about the logical data independence, that is the characteristic of being able to change the conceptual schema without having to change the external schema. There are three types of label. One is view label, another is logical label, and the third one is physical label. If we change in physical label, suppose there is not effect in the logical label. If we change in a logical label, that not be effect on the view label. So these are the data independence. Suppose we have changed the characteristic, being able to change the conceptual schema without having to change in external schema. In the logical data independence used to separate external label from the conceptual label. If we do change in conceptual view of data, the user view can be, data would not be affected. The logical data independence occurs at the user interface level. In the physical database independence, the physical data independence can be defined as the capacity of to change the internal schema without having to change in the conceptual schema. In these three labels, we can change in one label that cannot be affect to the another label. This is called data independence. Data must be, schema must be unchanged because we can change only the data. So this is called data independence. This is the overview of data independence diagram. One is external label, logical label, physical label, and this is the particular database. Physical data independence occurs between the logical label and physical label, and logical data independence can be occurred into the external label. If we change in the logical label, that cannot be, that can without having to change in the external schema. If we change in the logical label, then we cannot affect on the external label. In the, we can change in the physical label, they cannot be affect on logical label. This is called data independence concept. In the data independence concept, we can use to preserve the data security and data consistency. This is all about data independence. So we have discussed about the data independence. So brief about DDL commands, DML commands, because we can access the database by using these commands. So we can discuss about DML. This is the part of SQL, structured query language, and we will discuss in the second unit, but we have given the brief of DDL. Data definition language we can use for the definition purpose. Suppose we can create the table, this is called DDL command, because when we create the database, when we create the tables, when we create the particular instructor table, suppose we have example of instructor table, we can create table instructor, and these are the attributes that we can define in the particular table. So this create table comes to the DDL command. When we create about the database schema, then it is also called the DDL command. And after DDL, we can access that particular data by using DML commands, data manipulation languages. In the data manipulation language, manipulating the data organized by the appropriate data models. DML is also query language like a DDL. We can use that particular language for the manipulating the data. Suppose insert, update, select. These are the queries that comes under the DML commands. So two types of class of language that we can use. One is pure and one is commercial. SQL is most widely commercial language that we can use. In the pure form of language, suppose computational power and optimization purpose, we can use the relational algebra, tuple relational calculus, and domain relational calculus. These are the two type of languages that we can use. Suppose we have to design some particular database, we can use the pure language for the computational purpose and optimization purpose. So we can use relational algebra. In the relational algebra, we use some notations like projection, selection. These are the notation that we can comes under the relational algebra. This is the purpose of computational power and optimization. After the relational algebra, we can discuss about tuple relational calculus and domain relational calculus. These are the concepts that we can use in pure form of language that we'll use in computational power and optimization purpose. In the SQL, this is the commercial language that we can use in all the databases that are applicable in current scenario. In the SQL commands, there are two major types of categories. One is DDL, one is DML. DDL is used for the creating purpose. Suppose we are creating the tables, we are creating the databases, we are creating the constraint, we are creating the primary keys, and we have also give the authorization to the particular user. So, in that particular cases, we can use the DDL commands. After the creating the tables and databases and integrity constraints, we can use the DML commands for the accessing purpose like select, insert, update. These are the queries of SQL that can access that particular data from the help of DML. These type of queries comes under the DML commands. So this is a brief about DDL and DML that comes under the SQL portion, and today we have discussed about the introduction part of DBMS. Now in the next lecture we have discussed about the ER diagrams. So lecture 1 is completed. Thank you all.